tutorial for Chapter 2, Section 6, titled Perimeters and Areas of Similar Figures. This is the second day on this lesson, and these problems are going to use the idea of ratios of areas and perimeters to find out, to solve some problems. And so first of all, when we're looking at ratios of perimeters equals the ratio of sides, and that's what we saw in the first day. So let's write that down again. Ratio of sides equals the ratio of perimeters. And that's going to help us solve some of these problems. We're going to need to know that, and then the ratio of areas, so that equals the ratio of sides squared. So if we square the ratio of the sides or ratio of the perimeters, because they're the same thing, that will give us the ratio of areas. So we're going to use those concepts to help us with this problem. So it says a swimming pool is similar in shape to the volleyball court. Find the perimeter, P, and the area A of the pool. So they give us that area of the volleyball court, perimeter of the volleyball court, so let's see what we can do. Let's start with the ratio of the sides. So I'm going to set it up this way. 10 is to 18. So these are the two sides. I'm writing that as a ratio. And now I'm going to set this equal to the perimeter of the court over the perimeter of the pool. So I see that the perimeter of the court is smaller, and so it also is the 10 units going wide, and then 18 yards is the width of the pool, so I don't know what the perimeter is, so that's why I'm putting X there. So I can set these equal to one another because the ratio of the sides and the ratio of the perimeters are equivalent. So what I'm going to do to make the problem go a little faster is, well, actually I'd go ahead and could reduce the 10 to the 18, but I see that dividing by 10 is not so bad, so I'm going to leave it the way it is. And I'm cross multiply, so I'm doing 18 times by 60, and then I do 10 times by X. And so when I multiply the 18 times 60, gives me 1080 equals 10x. So again, I decided to leave this in the form it was because dividing by 10 is just going to knock off that 1 0, move the decimal one space to the left, and so that gives me 108 yards is the perimeter of the pool. So now let's go ahead and solve for the area of the pool. So remember, the ratio of the sides equals the ratio of the perimeters. That's why I was able to solve that. Now I'm going to use this concept. Ratio of areas equals the ratio of the sides squared. So I need to find the area of the pool. So I'm going to take 10 over 18, and I'm going to square those numbers. Square both the top and the bottom. And that's going to give me the ratio of the areas. So it's going to be 100 over 324. And so from that point, now I'm going to write down the ratio of, or the area of the court, because I know that is 200. So that goes in line with the 10, because the 10 was the width of the court. So I need to find the area of the pool. So I'm going to put the area unknown is down below. So I go ahead and cross multiply once more. So we're getting 100x equals, and then I multiply this way. So 324 times by 200 is going to give me 648 and then 2 zeros. So 64,800. So when I go ahead and do some division, I'm going to divide, it's going to take out those 2 zeros there. So x is equal to 648 square yards. So let's take a look at the next problem. And this one's going to be dealing with some circles. And so let's take a look at it. And when we are trying to find out the circumference of a circle, that's pretty much the same thing as what the perimeter is. Circumference is just the distance around. So let's say I want to find out what the ratio of the circumference is. So the ratio of the circumference is just going to be the same thing as the ratio of the perimeters. In this case, they give me the perimeters, or they give me the circumference, so I am going to just do, let's say, the big to small. Let's go big to small. So I'm going to take the large circle's circumference and divide it by the small circle's circumference. And what happens? Well, when I have common factors, like for instance pi is common, those will cancel each other out. I can also divide by 2, and I would have an answer, 9/5. That is the ratio of the circumference. Well, the ratio of the circumference is going to end up equaling the ratio of the radii. So I'm going to write that part down, equals the ratio of radii. And so the radii is just plural for radius. And so if I said this one is, so let's go with 9 inches, I could find out what the ratio of the circumference is. And you can see it fairly easily because the ratio of the circumference is 9/5. And if the larger circle has a radius of 9, then I want to find the smaller one. You can see that even if you cross multiply, we'd end up with 45 equals 9x. You divide by 9, and you see how you'd be getting 5. That's exactly what x should be, because 9/5 equals 9 over x. X must be 5. So you can see how the ratio of the circumference equals the ratio of the radii. Well, it goes along just as a ratio of the sides equals the ratio of the circumference. It's the same thing. These are just lengths, so you can always set up ratios of similar figures. So if I was to look at the ratio of area, of the areas, it would just end up being that 9/5 times by itself, squared. So it would be 81 over 25. And so that's what we'll end up seeing on tonight's assignment. So the key is to remember that when we are dealing with sides, then you want to find out the ratio of perimeters. You want to use the ratio of perimeters or ratio of sides. If we're dealing with an area problem, then we need the ratio of areas in order to solve. So those are the problems you'll see on tonight's homework. Good luck.